In this video, we'll graph the hyperbola y equals 2 divided by 3x plus 3 minus 1. The first thing we want to do is get it in a better form so we can see what's happened with the transformation. So if we factorize the bottom line, we find it's the same as 3 bracket x plus 1, and then we'll still have the subtract 1. So the transformations are now easier to see. So we can see that it's been dilated by a factor of 2 on 3, which has come from the 2 on 3 out the front of the hyperbola. From the x-axis, it's been translated 1 unit in the negative x direction, which comes from the x plus 1. So if you take the 0 of that bracket, you get x minus 1. And finally, it's been translated 1 unit in the negative y direction, which comes from the negative 1 out there. So what we can do now is we can find the y-intercept. So we have the y-intercept occurs when x is equal to 0. So if we put that in, we get y is equal to 2 divided by 3 times 0 plus 3 minus 1. So if y equals 2 on 3 minus 1, which equals negative 1/3. So our point becomes x is 0 and y is negative 1/3 for the y-intercept. The x-intercept is when y is equal to 0. So if we put this in, we have 0 is equal to 2 on 3x plus 1 minus 1. And if we add 1 to both sides, we have 1 is equal to 2 on 3x plus 1. Multiplying both sides by x plus 1 gives x plus 1 is equal to 2 on 3. Subtracting 1 from both sides of the equation gives x is equal to negative 1/3, which means that the x-intercept is x is negative 1/3, y is 0. Taking into account the translations of this graph, we know that our vertical asymptote is now at x equals negative 1, and that was given to us back here. We also know that our horizontal asymptote has been moved down in the negative y direction by 1 unit, so that's y equals negative 1. Our x-intercept occurred at negative 1 on 3, 0, and our y-intercept occurred at 0, negative 1 on 3. So graphing a positive hyperbola, we know that it will have one section in the upper right hand corner, and it will have one section in the lower left hand corner. And as you can see, the hyperbola graph approaches the asymptotes but never quite reaches them, so the distance tends towards 0 as they go off to infinity. Lastly, we can talk about the range and domain of the function. So we know that the domain is all the available x values that can go into the function. So having a look at our function or equation, we know that x equals negative 1 gives 2 divided by 0, and anything divided by 0 is undefined. So every single x value in the real number system is allowed, excluding negative 1. And the range, which is the set of all the y values that come out of the function, are all the real numbers, which you can see on the graph, excluding negative 1, because there's no x value here that will be able to give us 0 for what I highlighted in yellow in order to give y equals negative 1 as a value. So our range excludes negative 1 because we never quite get to that number. On this slide, we've just got a computer-generated graph which shows the vertical asymptote in red as x equals negative 1 and the horizontal asymptote as y equals negative 1. And then we have our x-intercept at negative 1 on 3 and our y-intercept at negative 1 on 3. And over on the right hand side, our domains have just been restated, which we found before.